Like Melissa said, I'm a limnologist with Environment and Parks. So my focus is really looking at water quality throughout the entire basin. So I deal a little bit with the monitoring programs, a little bit with approvals, a little bit with compliance. And today I'm going to give you a really high-level overview of the North Saskatchewan River. So to start, here's a basic overview of what my talk's going to look like. I'm going to give you some basic backgrounds on the characteristic of the basin. I'm going to talk a little bit about historical water quality, some of the changes that have gone on in the basin. I'm going to touch on some of the differences in current water quality and point source influence versus non-point source influences, and then touch a little bit on some of the management activities that we've got going on in the basin. To start, and to set the stage for the rest of our talks today too, the North Sask Basin is about 80,000 square kilometers. It spreads through our province, includes the Battle, passes through Saskatchewan, and ultimately drains into the Churchill River. But within our province, we have 12 major subbasins. And so they vary from our headwater basins, which are, of course, really rocky, mountainous, forested areas, to those subbasins in the eastern part of our province, which are dominated by agricultural activity. They have shallow, sloping prairie conditions and soft soils. So along with that, we get changes in vegetation from forestry to ag, like I said. We get changes in population, we get changes in precipitation patterns, and all of these things influence what happens in the downstream water quality in the NSR. When we look at flows, most of our water annually comes from 3 or 4 major headwater subbasins. So the Clyde, the River, the Brazeau. As we head downstream, those prairie basins that we have in the eastern part of our province actually contribute very little overland flow. So this is a figure taken from PFRA's data set, and it shows the areas in orange that are non-contributing. So basically what that means is that in a median year, 1 every 2nd flood year, that orange area provides little or no overland flow or runoff into the downstream creeks and rivers. So these types of differences in where our flow is coming from influences what's going to be coming into the river with that flow. When we look at a hydrograph of the NSR, there are really 3 peak periods of flow that we see. We see a big pulse of snowmelt in the spring, which comes from some of these local areas, prairie snowmelt sort of thing. Then we get a big pulse later in the spring, early summer, when that mountain melt starts to come in, which makes up most of our flow. And then occasionally we get these incidental storm events that happen later in the summer, which can also bring various chemicals and nutrients into the water. So in environment, we've been monitoring various stations throughout the basin on and off for about 50, 60 years. These black points that I'm showing you are our less frequently monitored sites. They're only monitored sort of once in a blue moon, and we use them as synoptic studies, sites, or ecosystem health studies. They're the locations where we try to do more detailed spatial surveys. The green points on that slide show the federal sites that are managed by Environment Canada. And they're long-term sites. They've been in place for decades. And then finally, the 3 blue sites are our long-term monitoring stations. So there's one up by Rocky Mountain House, there's one upstream of the city at Devon, and one downstream of the city at Pecan. So those 2 sites, Pecan and Devon, have been monitored since the 60s. And we do monthly monitoring there. So we look at inputs of nutrients, concentrations of nutrients, and ions and other chemicals like metals and organic contaminants. And all of this information that we get from these monitoring stations are important for looking at long-term trends and how the river is changing. So if I back up and I go back to 50, 60 years ago when we put these stations in place, the province was a much different place. Since then, our population has increased from under 1 million to over 4. A vast majority of that change has happened in the North Saskatchewan Basin. So something like 40% of the provincial population occurs within our region. Of that 40%, 75 is in the capital region itself. And so this is a series of slides I've taken from a website called Alberta Tomorrow. And it it's a zoom in of the capital region itself, and it can show you how that land cover and how that population base has changed within this capital region. So the yellow is natural grassland, the green is forest, and you'll watch as I flip through these slides, which is intuitive to most of us, that the pink area, which is urban, is going to grow, and that brown area, which represents agricultural land use, is going to change. So we go from primarily agricultural or grassland and forest to more ag, more urban expansion, to where we are right now in our capital region industrial heartland area with a really big urban base and a lot of agricultural land use. So this has major impacts on how water quality has changed in our region here. Outside of that capital region, we also have the industrial heartland, which is an important source impact on the river. Within this industrial heartland, we have several dozen industrial facilities, whether they're chemical plants, upgraders, refineries, all discharging into the river. Some on a continuous basis, some on an intermittent basis, some even take their waste and direct it to the Alberta Capital Region wastewater facility. But ultimately, effluents from these facilities also get into the river. On top of the industrial growth that we've seen around us in the city, we've also seen expansion in the headwaters of increasing oil and gas. We've seen increased forestry in the green zone. We've seen increasing growth in some of our smaller municipalities, and of course, agricultural activity. So, like I said, these all have impacts on water quality. They bring in nutrients, they bring in chemicals, they can cause growth in plants like macrophytes or algal growth. They can influence the ability of fish to survive, whether it's because of low oxygen conditions or contaminants. And they can bring in big sediment loads, which also bring in metals and various contaminants that we're concerned about. So we have all these big changes going on within the basin. Now, despite these big changes and what seems like on the surface like it'd be increasing stress, we've actually seen a lot of improvements in the river. So this is a slide taken from the City of Edmonton's archives from the 1950s, and it's showing a garbage dump located on the banks of the river that's burning. And if you listen to some of the stories that we have about the history of the NSR or look at some of our records, it's a pretty dirty history within at least the capital region, where we had slaughterhouses and logging facilities and all sorts of waste going straight into the river. This slide is taken from a report that was prepared by Boudelier in 1984, and it's been adapted with some more recent data from Gord Thompson at the NSWA, and it shows on the bottom distance downstream from Edmonton to Lloyd. On the x-axis, it's the concentration of oxygen under ice. So if you look at these lines, which start in the 1950s in the purple and green, you can see that as you travel downstream from Edmonton to Lloyd, the river became virtually anoxic by the time it hit Vinca or Wiscatnow. Over time, you'll notice that those lines get better and better and better, which means that there's more and more oxygen under ice, which is a good thing. It means our fish aren't going to die. And a lot of this has to do with major changes in the way we've dealt with wastewater. So the Gold Bar wastewater treatment facility came online and started treating waste. The Alberta Capital Region came online, and we started building dams in the headwaters, which controlled how winter flows varied, making winter flows higher than they used to be and summer flows a little bit suppressed. But all of this has good impacts on the oxygen level and the winter nutrients in the river. This is a slide taken from a trend report that was done in 2012. Feels like it was in the 1900s. In 2012, and it shows through time from the mid-'80s to now how phosphorus concentrations have changed on the river. And you can see that prior to 1998, there's the first line, and it shows that phosphorus concentrations were much higher. And that step change that we see coincides with upgrades at the wastewater treatment facility in the city. If you look carefully, there's sort of another step change that happens around 2005, and that's a second upgrade that happened at the Alberta Capital Region wastewater treatment facility. So you can see the direct impact that the way we treat our point sources, our effluent, has on things like nutrients in the river. Similarly, this is a trend of ammonia. downstream of the city and how it's changed over the past 20, 30 years. So you can see a similar sort of pattern there. Now, all of these changes that we've seen in nutrient parameters or chemistry within the river have direct impacts on what lives in the river. So this is a slide taken from 2 different studies that were done on invertebrates in the river. On the y-axis, we're moving downstream, sites that were upstream of the city all the way downstream of the city. On the x-axis, I'm showing you the abundance of invertebrates. So these are various types of bugs that live in the water, in essence. And some of them are really tolerant of pollution, and some of them are really sensitive in pollution. So if you look at the study that was done in the top panel in the mid-'80s, you can see that most of those bars are dominated by orange and red. Those are our really pollution-tolerant species, like our chironomids or our bloodworms or our oligochaetes. If you look at the bottom panel, which is the exact same study design, but it's forward in time 20 years into late 2008, you can see that there's been a big shift in the proportion of what type of invertebrates are present. So instead of being dominated by orange and red, we're seeing higher proportions of green and yellow, and in some of them, blue. And these are our really sensitive species. So for context, they look like this. So we're moving from species on the right, our bloodworms and our worms, to those on our left, which are more like mayflies and caddisflies. So this is a good thing. We've seen direct effects on the aquatic ecosystem from the changes we've made on our point source inputs. So that sort of takes us to now. If we're trying to manage inputs into the river, we have a balance between managing our point source inputs and our non-point source inputs. These are a really simplified way of looking at things, but point source inputs are things that we have direct control over in a certain sense. Non-point source is the stuff that comes off the watershed that isn't necessarily a pipe that we can just turn on and off. And the effects of these 2 different types of pollution are going to vary with flow regime, with season. So I'm going to give you a couple examples of 2 different types of these inputs, and then give you some examples of projects we're working on to manage some of them. So an example of some of the point sources that we see could be chloride. So this slide shows some results from a synoptic survey that we did a few years ago. We do these every few years. And what a synoptic is we take basically a parcel of water and we follow it all the way downriver. And so on the x-axis is the distance downstream from the headwaters to the border. On the y-axis is a concentration of chloride in that parcel of water. And for reference, on top there are little arrows that are showing you some of the major tributaries or inputs coming in to the river as that parcel of water travels downstream. The red line is samples that were a sampling regime that was taken in March, so really before everything's melting and flowing, low flow sort of late winter conditions. The yellow line is June, are really sort of heavy flow, high flow events, and then green is late fall. So you can see as we move downstream, the biggest pulse that we're seeing of chloride in the winter is happening through the city reaches. If you look at the yellow and green lines when we have different flow regimes, that pulse is not so obvious. And part of this is because most of the chloride is coming from road salts inputs, melting and stormwater inputs at the end of the sort of late winter spring period. But it shows, for example, how the timing of inputs and the timing of flow is going to vary the concentrations that we see in the river. Another example of when we can see point source inputs is, for example, dissolved phosphorus. Similar to chloride, we see a big pulse of dissolved phosphorus downstream of the city when we have that March synoptic survey, but it's not quite as obvious in the other 2 surveys. It's not there. We have high loading of dissolved phosphorus and chloride at certain times of the year from upstream sources. But this gives you a sort of sense at how chloride concentrations change based on source and timing. So one of the programs that we're working on at Environment and Parks is the effluent characterization. And this program, Alyssa's going to talk about it next, is part of a much bigger initiative where a lot of stakeholders who are involved in this IH Capital Region reach have been part of a stakeholder committee for about a decade, working together on how to manage loads in this particular area of the river. So Alyssa can give some examples on how we deal with some of those point sources and how we figure out when they're affecting the river and how we can manage them. On the flip side, if we look at non-point sources, the sort of biggest concern that we have with non-point sources, it seems right now, is suspended solids. And that's because suspended solids, when they come in, often bring lots of other things with them, like metals or other forms of nutrients. So this particular slide is taken from the pilot water quality objectives that were prepared by Darcy McDonald in 2013. And it's based on some other research and analysis that we've done in our group with some loading tools that Alyssa might also be able to speak to. But it shows when, based on flow regimes, so highest flow on the left of the bottom axis, lowest flow on the right, and concentration of suspended solids on the y, it shows us when we see the big pulses of suspended solids. And like is intuitive, it comes in the high flow events. Now, if we flip back to the same sort of layout I showed you a moment ago with the synoptic studies, you can see a similar thing where the high flows that we see in mid-June that come from our headwaters are bringing in a lot of that suspended solids, which is in that blue line in the middle there. But when you compare that to our lower flow events in the red and the green, we're not seeing those major pulses of suspended solids coming from the river. And unlike when I showed you the slides of the chloride or dissolved phosphorus, we're seeing this increase in suspended solids happening right from near the headwaters and continuing as we head all the way downstream. Similarly, we see a matching sort of trend when we look at particulate phosphorus. So earlier I showed you about point sources of phosphorus of dissolved phosphorus coming from sort of the capital region. If we look at that particulate phosphorus that we expect to be binded to a lot of the suspended solids, we see a pattern that matches really closely to this previous slide I showed you, with big increases of particulate phosphorus happening at the same time as those increases in suspended solids. Now, if we're going to manage loads and we want to manage things like nutrients in general, we need to have an understanding of both of these types of inputs. So on the top here, I've got the synoptic showing the particulate phosphorus on the left that was coming in predominantly in that June pulse. On the right, we've got the dissolved phosphorus, where we see a big pulse of it coming through the city in the March sampling period. And if you look at total phosphorus, which is the combined form of all the phosphorus we see in the river, you can see it's a combination of both of these. We see the yellow peaks, which match the particulate forms. We see the red peak underneath with March, which matches what we see in the dissolved fractions. So we really have to look at all of the types of nutrients that are coming in. We have to be aware of both point and point sources and how those change with flow and inputs. So, like I said, when we're managing point sources, they're in some ways a little bit more straightforward. We regulate all point sources that go into the river under the Environmental Protection and Enhancement Act. So any direct discharger has to apply for an approval, and it gets approved based on loading rates or water quality limits or best available technology. And we have other programs like I mentioned, the effluent characterization program. There's load management policies being developed. On the flip side, the more complicated piece is really this non-point source load. So the first thing we need to do is identify sources, which can be a lot more resource intensive, because instead of having your 3 sort of long-term stations or looking at trends or your direct dischargers and knowing what's in their pipe, you need really high quality and high resolution spatial data. And then you need that over a whole range of flows in order to really know when these nutrients are coming off the landscape and where they're coming from. So that requires greater synoptic studies, that requires tributary monitoring, and that requires flow-aided studies, which we, as Alberta Environment, don't do probably as much as we want to. So that's where we get into forming partnerships with some of our other stakeholders. So Steph's going to talk a little bit about suspended solids, I believe, in the river, and we're working with EPCOR and NSWA to look at developing a greater tributary monitoring program in the province so we can get at some of these other sources. And finally, the really bottom line on managing non-point sources is setting up watershed management plans, which involve multi-stakeholders, because it's not going to be one point source discharger that we're dealing with. It's going to be a combination of efforts from municipalities, from agricultural land users, from urban centers, and other sources that are driving these changes in non-point source loading. So the very last slide I'm going to show up is on this really big picture management initiative that we're dealing with in the government. So some of you may have heard of the land use planning initiatives, and within the regional plan for the North Saskatchewan region, we're developing a surface water quality management framework. So this is a really high level tool where we set objectives on the ambient water quality in the river. So for example, in the south, when they developed their management framework, they set 50th. They said that the median water quality for a variety of different parameters should be maintained. And so it's the same sort of thing we're looking at the North Saskatchewan, where we pick a variety of different indicators, whether it's a nutrient parameter or a suspended solid parameter. And we've committed to saying we want to maintain the river in this ambient condition into the future. And every year, the government is committed to reporting on the changes in those indicators. And if there are changes, we've committed to managing them, to go out, to figure out where they're coming from, and to actually pull some of those levers and change point source inputs, or to actively resource some of the tools that we can use to manage non-point sources. So this is something that I expect to come out in the foreseeable future. And we're going to be looking for a lot of stakeholder engagement on this and input on what responses are to the indicators that we've chosen, and how we're going to deal with managing the river. So I really want to encourage people to come out and give their input when this initiative starts being publicly engaged upon.